Hello student, in this video we will discuss about the phasor diagram of a transformer on load. In the previous lecture, we discussed about transformer on load. There we learned about the theory, how a transformer works when it is loaded. When the secondary terminal is connected to a load, how the transformer behaves. Okay, now loads basically are of three types. First is resistive load, second inductive, the third is capacitive. So we'll have a quick review about the phasor diagram for these three loads. Okay, so basically when there is a resistive load, it means voltage V and I both are in same phase. Okay, it means the power factor cos of phi is what? It is unity. It is unity. Okay, for inductive load, it is V. The current lags by an angle phi. Okay, this is what we are not considering ideal or pure inductive load. We are considering some practical load. So what will happen? The current I will lag by an angle phi. So power factor is what? Cos of phi is what? It is lagging in nature. And for the capacitive, it is what? It is V. Then current I is leading by an angle phi. So cos of phi is what? The power factor is what? It is leading. Okay, this is the basic for power factor. Okay, now we'll quickly brush up theory about the transformer on load. Suppose when V is connected, what happened? There is a flow of current I naught and there is a establishment or flux phi is set up in the primary winding, and due to this flux phi, E1 is produced, and this flux phi is linked with the primary winding of a transformer. And when it is linked with the primary winding of a transformer, what would happen? It produces another EMF, which is self-induced EMF in the primary side, that is E2. It is mutually induced EMF. This is E2 in the primary side or secondary side. And when there is a load connected, there is a terminal voltage V2. When there is a load connection, what will happen? There is a flow of current I2. When there is a flow of current I2, there is again another flux phi 2 dash established in the secondary winding because of this I2, which is in opposite direction to that of main flux, which demagnetize this main flux phi. And this is what? This is phi 2. This phi 2 dash. This is set up because of this I2. Okay, so it opposes the main flux. It means this main flux get demagnetized. Now what would happen? This E1, the potential of E1 or the value of the E1 goes down, because E1 depends upon d phi by dt. As the value of flux, main flux, goes on decreasing, what will happen? E1 also decrease. As E1 decrease, the potential of E1 is higher than E1. What will happen? There is another flow of current, that is I2 dash, which is compensating this flux. When this I2 flows into the winding, what will happen? There is another flux produced in the primary winding, which is linked with the secondary winding, known as phi 2 dash. This is phi 2. This is phi 2. This is phi 2 dash. This phi 2 dash is in phase opposition with the phi 2. So both the flux are neglecting. Okay, just we summarize the whole process. What will happen when there is a application of V1? I naught flows in the primary winding. As I naught flows in the primary winding, flux phi is set up, and because of this flux phi, which is linked with the primary winding, E1 is induced in the primary winding, known as primary induced EMF. This flux phi linked with the secondary winding and induced EMF E2. When the terminals are open, E2 is equal to V2 when terminals are open. But When there is a load connection, what will happen? There is a flow of current I2, and this I2 establish another flux phi 2, which is in opposition to phi. It means phi get demagnetized. When phi gets demagnetized, what will happen? E1 reduces. As E1 reduces, V1 is greater than E1. There is another flow of current which is known as I2 dash, and because of this I2 dash, it is flowing into the primary winding. It established another flux phi 2 dash, which is in opposition to phi 2 dash, which compensate the phi 2 dash, which means phi 2 dash and phi 2 both are equal in magnitude, but their direction is opposite. So what will happen? They will cancel out each other. So phi 2 dash is equal to phi 2, both are equal in magnitude but in opposite direction. So they cancel out each other. Okay, this is what the basic summary about transformer on load. So it means here in this figure, I0 and I2 dash, these are the components of primary current. It means I1 is equal to I0 plus I2 dash, the phasor sum of this. Okay, and in the previous lecture we established a relation I2 dash is equal to KI2. It means I2 dash is equal to KI2. Okay, now here we are taking K as 1, means K is unity. It means N2 is equal to, and N1 means isolation transformer. Okay, when K is equal to 1, N2 is equal to N1, it means it is, what will happen? V2 is equal to V1. It is known as, at that time, it is known as isolation transformer. Isolation means it is separating the primary circuit and secondary circuit. This circuit is not electrically coupled. It is what? It is magnetically coupled. Okay, so this is what isolation transformer. We have two equation. I1 is equal to I0 plus I2 dash, and I2 dash is equal to KI2. We are assuming that K is equal to 1. It means I2 dash is equal to I1. Means the magnitude of these current are equal, but they are in opposite direction. Okay, so it means we are considering one figure for resistive load. Means the load is what? Resistive. Now this is V2. V2 is what? It is a terminal voltage, and this is I2 secondary current. What sort of relation is between them? It is unity. Okay, it means if it is suppose V2, it means it is in the same direction I2. Okay, the power factor is what? At secondary side, it is what? For the load, it's unity. Okay, when the transformer was on no load. Okay, when the transformer was on no load, so what sort of phasor we drawn over there? It is phi. Okay, this is V, this is V1, and it is having two component. I0 is having, at that time in that lecture, I0 was having two component, I mu or Im plus IW, means or we can say Im plus IW, the phasor sum of these. Okay, so this is what? This is Im, this is IW, and the resultant of this, it was I0. Okay, this is what? The phi naught, power factor angle at no load. This is V1. Then this is what? E1, and this is E1 is equal to E2. It means the same. This was the figure when the transformer was on no load. Now considering the same, we'll draw when the transformer is having resistive load. Okay, so this is what phi, the magnetic flux. This is V1. Okay, now I naught. Let us suppose this is what I naught, and here we have one relation, I1 is equal to I naught plus I2 dash. Okay, so I2 dash will be on the same V1 axis. This is what I2 dash, and the resultant of these, what it is, I1. So this is what the I1 is. This is I1, as I1 is equal to I naught plus I2 dash, the phasor sum of this. Okay, so we can draw the phasor like this. Okay, now V1, the second is what, E1. We can draw E1 as in opposite direction, as it opposes, E1 opposes V1, so it is what, E1. Now this is what, E2. Let us suppose E1 is equal to E2, so we can write like this. It is what, it is E2. Okay, and this is V2. So let us suppose this is E2, and this is what, this is V2, and I2, as we drawn earlier, V2 and I2 both are in same phase. This is what, I2. This is the whole phasor for no load, for resistive load. Okay, now this is what, this is the power factor angle. This is phi 1, and the power factor angle for secondary side, this is what, the primary side, and this is the secondary side, and power factor for the secondary side is what, it is cos phi 2 is equal to 1. Phi 2 means what, it is for the power factor angle for secondary side. Okay, so this is for the resistive load. Now considering the inductive load, most of the loads are inductive load. So this is what, phi, then this is V1, this is I1, oh sorry, I naught, then this is what, this is E1, suppose it is E2. Now this is what, V2. Okay, now we have relation I1 is equal to I naught plus I2 dash. Okay, and I2 dash is equal to I2. I2 dash is equal to I2. It means, now what will happen, this is I2. Relationship between V2 and I2 is what, it is, what sort of load is there, it is inductive load. It means it is a lagging load. So the phasor will be like this. This is what, V2, and this is what, I2. I2 is lagging by an angle phi 2. Okay, if we tilt it, it will like this. This is what, V2, this is what, I2. The same we are keeping here. So this is what, this is I2, and I2 is equal to I2 dash. So it means, but they are in opposite direction. It means this is what, this is I2 dash. Okay, getting the point. So the resultant will be like this. Drawing a parallelogram, this is what, this is I1. So this circuit is what, the upper circuit is for the primary phasor, and this is what, the secondary phasor. Now from I1 to V1, it is what, it is phi 1, power factor angle for primary side, and this is what, power factor angle at secondary side. This is what, phi 2. Okay, now we are considering for capacitive load. Okay, the load is what, capacitive. It means V2 and I2 is what, this is V2 and this is I2, the leading current. Okay, this is what the phi 2 is. Now we are keeping this here. It means this is what, V2, so this one is I2. Okay, so keeping this here, it is what, I2. It is a capacitive load, so it is what sort of power factor, it is what, leading. So this is I2, and I2 dash is equal to I2. It means the magnitude is same, but they are in opposite direction. It means this is what, this is I2 dash. Now making a parallelogram, this is what, this is I1. This is the primary current I1. This is the compensating load component current I2 dash. the no load current I naught, the secondary current I2, and this is what V2. The power factor angle between this is what it is phi 2, and this is what phi 1. Phi 1 is what it is power factor angle at primary side, and phi 2 is what it is power factor angle at the secondary side. So this is what the figure for phasor diagram for capacitive load. Okay, thank you.